Hey guys, so today we're going to talk about factoring. It's a little bit different than what we've been doing. We did factoring out the GCF, but it's going to be, and we're going to do that more, but we're going to do a different type of factoring. So before I teach it, I want to show you something. If I gave you a problem like this, we know the answer equals this because it says so. But if I was to solve this, parentheses means multiplication, so you would distribute x times x and you would get x squared. Then, sorry, I'm so bad at this. It's late. Then you would distribute x to the 3 and get positive 3x. Then you would go and you need to distribute 2 to everything. So 2 times x is 2x. And then you'd have distribute 2 times 3, which is 6. And then the last step would be, which you guys should already know, is to combine like terms. So the middle terms can be combined. So you bring down the x squared, because he has an exponent of 2 and no one else does, so you can't combine him with anything. And 3x plus 2x turns into 5x plus 6. And you can see that matches the answer here, right? So this turns into this. That is called multiplying, distributing, FOIL. You can use the box method to solve that, but what we're going to be doing today is we're going to be going backwards. So we're going to go from a problem like this, or should I show you this? I'm going to give you a problem like this, and I'm going to say factor it. And that means turning it into this. It means going backwards, the opposite of distributing. And factoring, as it says right here, it's turning something into a multiplication problem. So what I just did was we took this multiplication problem, we simplified and got this answer. But now if I say factor, we're going to take a problem like this, which is not multiplication problem, and turn it into a multiplication problem. And it's not as easy. So this lesson will probably take all week to kind of learn. But there's a few things that I want you to notice here. Since we're going backwards, we're going to definitely have to think about some stuff. But I want you to look at this first term of the binomial and this first term of the binomial. It's x and x. And when we multiply the x times the x, we got the x squared, which is right there, right? So the first two terms multiply to give you your first term when you simplify. So when we're going backwards, keep that in mind, that we know that this is going to break into two things that go here. Then if we notice, I'll do blue. If we multiply the 2 and the 3 out, that's our last thing we distribute. We get the 6, right? 2 times 3 is 6, which we get here. So we know that the last two numbers, the two numbers that go there, multiply to give you the last term. But they also affect the middle. So they also, if you see right here, they add, what's 3 plus 2? My Siri's going off. They add to give you the middle term. So when we're going backwards, we know the first two terms that go here have to multiply to give you this. We know the last two terms have to multiply to give you the last term, but also add to give you the middle term. And that's what I have here highlighted in red. So you want to figure out what two numbers multiply to give you the last term and add to give you the middle term. So let me just do an example so you can understand. We're going to do the same example, which we have the answer right there, but I just kind of want to show you the process. So if I say factor this, we're adding here, we're going to turn it into a multiplication problem. So it's going to be something times something else. That's our goal. And we know, like I said, here, these terms, as you can see right here, they have to multiply, these first two terms have to multiply to give you the x squared. So what two things multiply to give me x squared? Well, x times x does. And then the last term, or the last two terms that go here and here, these have to multiply to give you 6, but add to give you the middle. So, and it's going to get tricky. This one, first figure out what multiplies to give you 6. Well, 1 times 6 gives me 6, and 2 times 3 gives me 6. Those are the only two options that multiply to give you 6. So it has to be either 1 and 6 go here, or 2 and 3 go here. And so you got to keep in mind which one of these are going to add to give me 5. Well, it's going to be this, because 2 plus 3 equals 5. So these are the numbers we're going to use. So what goes here is a positive 2 and a positive 3. And we just turned this problem into a multiplication problem. And how do you check your work? You distribute. And if you distribute, you'll get this problem over here. Now, some people are going to say, oh, well, what if I thought it was x plus 3 times x plus 2? What if you put the 3 here and the 2 here? It doesn't matter. It's not going to change it as long as you have the right sign and they're both positive. So that's how you factor. I'm going to do another example, but I just want you to understand what factoring is. You're turning it into a multiplication problem. You're going from something like this and you're turning it into a multiplication problem. So let's try this one. If it ever gets there, it's loading. Okay, so this one, we're going to factor. So we've got our thing here. Now factor means turn it into a multiplication problem. So we're going to make our little parentheses there. And now remember, the first term, we'll use red. The first term that goes here and here, remember, they have to multiply to give you the first term. So what two things multiply to give me x squared? Well, x times x. So x times x is x squared. And now the last terms of the binomials that go here and here have to multiply to give me 6. But remember, they have to, it says right here, they have to add to give you the middle. So we've got 1 times 6 gives me 6. Or 2 times 3 gives me 6. Remember, these are the only options to get 6. So out of these, which one adds to give me the middle term? Now, adds, or you can say subtracts, because adding a negative is like the same thing as subtracting. But anyways, we've got 2 and 3. That does not add up to give me 7, but 1 and 6 does. So we know we're going to put positive 1 and positive 6. And that's my answer. This is factored. X plus 1 times x plus 6. If you distribute or multiply it out, which you should do that to check your answer, x times x is x squared. Distribute the x to the 6. X times 6 is 6x. Then you distribute 1. 1 times x is 1x, or just x. And 1 times 6 is 6. Then the last thing you do is you add the middle terms or combine like terms. 6x plus 1x turns into 7x, and you bring down the plus 6. Now, does this match the original problem? Yes. And if it does, then you did it right. So this is factored. Let's try one more. Maybe 2 more we should try. So this one, we're going to factor this problem. So we know we're going to turn it into a multiplication problem. Remember, the first 2 terms that go here and here need to multiply to give me x squared. So what multiplies to give me x squared? X times x. Is it always going to be x times x? No. It's just coincidence right now. And then the last 2 terms, what goes here and here, have to multiply to give me 8 and add to give me 9. And that's what this little reminder is. You have to figure out what 2 numbers multiply to give you the last term, but adds to give you the middle term. So you always start, don't worry about the adding part. Always start with what multiplies to give you the last term. So what multiplies to give me 8? 1 times 8 gives me 8. 2 times 4 gives me 8. And that's it. 4 times 2, same thing. So these are my only options here. Out of these, they both multiply to give me 8. We have to figure out which one adds to give me 9. Well, 1 plus 8 is 9, so that works. And 2 plus 4 is 6, so that doesn't work. So this doesn't work. We're going to use this. So it's positive 1 or positive 8. And how do you check your work? I'll just do it here. You distribute. So my answer is x plus 1 times x plus 8. Now, if you guys are starting to see a pattern and you can see it and you can do it in your head, that's great. So anyways, you're going to distribute here to check. X times x is x squared. X times 8 is 8x. This is good practice for multiplying. 1 times x is 1x, and 1 times 8 is 8. Then you combine the middle terms because they're like terms. You bring down the x squared because it can't be combined with anything. 8x plus 1x is 9x, and you bring down the plus 8. So does this match the original problem? Yes. So my final answer is this. This is factored. Let me see. I'm going to do... Oh, now I want you to try this problem on your own. So you're going to factor this. I don't know why I did that. That's ugly. You're going to factor this problem and see what you get.